Objective, writing function rules. Vic number 1, when the x value in a table is 0, the corresponding y value is the constant in the rule. This constant is a helpful hint when finding the pattern that is the pattern that is the function rule. So you want to find the pattern for the function rule. Ask yourself, what do I do to the x value to get the y value? You're looking for a pattern. Writing a rule from a table. So in example number 1, x is 1, our output is 1. If x is 3, our output is 9. If x is 6, our output is 36. And if x is 9, our output is 81. So you should ask yourself, what can I do to 3 to get 9? When you put in 3, you get out 9. And the same thing has to be true for what can I do to 6 to get 36? So how do you go from 6 to 36? The x value times itself. So 1 times itself, 1 times 1 is 1. 3 times itself, 3 times 3 is 9. 6 times itself, 6 times 6 is 36, and 9 times itself is 81. Now we've talked about squaring numbers. A number times itself, this is x to the first power times x to the first power gives you x to the second power. So our rule is y equals x squared. Or you could write it in function notation, f of x equals x squared. Example number 2. Here we have our table, our x values, and our g of x values. So in this case, our function is called g of x. We plug in 1, we get out 3, in 2, out 6, in 3, out 9, and plug in 4, we get out 12. What can I do to 2 to get 6? The same thing has to be true to what can I do to 3 to get 9. Now you might see that 1 times 3 is 3. 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. So you can tell that the pattern is multiplying whatever the x value is by 3. So we could write y equals 3x, or in function notation, since our function is called g of x, write g of x equals 3x. Example number 3. So here's another data table. From Vic number 1, 0 is a helpful hint. The only thing I can do to 0 to get negative 4 is to subtract 4. So look at 0. Our x value is 0. You always want to focus on that if it's in your table. So to go from 0 to negative 4, you simply subtract 4. Well, does this always work? Does y equal x minus 4 for every value in the table? If it doesn't work for every value, then this is not the rule. So, negative 2, plug in negative 2. Negative 2 minus 4, that's negative 6, so it works. Negative 1 minus 4 is negative 5. It works. We already know 0 minus 4 works. And 1 minus 4 is negative 3. So this works as well. So does it work? Yes. All right, example 4. Again, 0 is in the table. Here it is. 0 is the input. The output is 1. And you might be thinking, well, how do you go from 0 to 1? The only thing that you can do is to add 1. Okay? So we say our number plus 1. Well, 1 plus 1 is 2, not negative 4. 2 plus 1 is 3, not negative 9. So it has to be more than just add 1. We've done a previous example with multiplication. So let's work backwards and figure out what was the pattern. So if we're working backwards, we're not going to add 1, we're going to subtract 1. So look at your y value. Subtract 1 from negative 4. You get negative 5. How do you go from negative 5, or from 1 to negative 5? Well, you multiply by negative 5. Okay, let's try it again. Negative 9 minus 1, because that's the opposite of plus 1. Negative 9 minus 1 is negative 10. How do you go from 2 to negative 10? Well, you multiply by negative 5. So if I'm multiplying whatever my x value is by negative 5 and then adding 1, it should give me my output. Let's try it again. Negative 14 minus 1 is negative 15. So 3 times negative 5 is negative 15, plus 1 is negative 14. So y equals negative 5x plus 1 is the rule for this function. Example number 5. This puts it into the context of workers and the number of iPads programmed. So if you have one worker, they program 13 iPads. If you have 2 workers, they program 26. 3 workers, 39 iPads programmed. 4 workers, 52 iPads programmed. So we can define some variables. W equals the number of workers, and P equals the number of iPads programmed. So P for programmed and W for workers. Now you can use X and Y or any variables that you want. I just chose workers and programmed, so W and P. So you put in workers, you get out iPads programmed. So I can set up this function rule. P is the output, and W has to be on the other side of the function. W, something happens to it to get our number of iPads programmed. Well, you can see the pattern. To go from 1 to 13, we multiply by 13. 2 to 26, multiply by 13. Each time we're multiplying by 13. So that's our pattern, and we can write it as a rule. 13 times W. The workers times 13, that's 13W. And that's going to give us these values, the number of iPads programmed. You can also write it in function notation. P of W equals 13W. That's the same thing as writing P equals 13W. All right, example 6. Number of hours and total pay. So if you work 4 hours, you make $32. If you work 6 hours, you make $48. If you work 8 hours, you make $64. And if you work 10 hours, you make $80. So let's define some variables. Number of hours, so I called it H. H is the number of hours. Total pay, that's the money that you earn. So M equals money earned. How much are you making each hour? Well, 4 to 32. How do you go from 4 to 32? You multiply by 8. 6 times 8 is 48. 8 times 8 is 64. And 10 times 8 is 80. So each hour that you're working, each hour means multiply the hours by 8. And that will give you your money earned. You could also write it in function notation. M of H equals 8H. Writing a function rule from word problems. Suppose you borrow money from a relative to buy a lawnmower that costs $245. The secret word is John Deere. So we're talking about John Deere lawnmowers now. You can charge $18 to mow each lawn. Write a rule to describe as a function of the number of lawns mowed. So we need to define our variables. N is the number of lawns mowed. Okay. P of N, so this is in function notation, like the previous problem, is the total profit. P stands for profit. N is our input. That's the number of lawns that we mow. Well, in the problem it says you can charge $18 to mow each lawn. Keyword here being each. We know each means multiply. So 18 times the number of lawns you mow is going to give you how much money you earned. Well, this lawnmower cost $245 and you borrowed it from someone, so you have to pay that money back. So whatever you earn, you have to subtract $245 and that will be your profit. So we can write in words, profit is 18 times the number of lawns mowed minus the cost of the lawnmower. So P of N, that's our total profit, is equal to 18 times N, $18 per each lawn mowed, minus the cost of the lawnmower.